Hello and welcome to this RiverSec webinar. My name is Janne Kauhanen and I'm joined today by Andrea Barisani, the head of our product security department, talking about anything from microchips to megatrends, how we're building secure products in a connected world. So, Andrea, what inspired sort of this RiverSec approach to product security and how has it evolved over time?
Yeah. Hello, everyone. I'm Andrea here, calling from Trieste, Italy. So yeah, I lead the product security team, and I'm very proud of the fact that very recently my team hit the 20 years anniversary of its inception, which of course comes before RiverSec, but I guess that's part of the RiverSec story, which is a combination of a lot of different talented companies going for different phases and then joining together. So the journey started 20 years ago as InversePath, a company which I co-founded with my colleagues, which are now part of our product security team. And then from there, we transitioned to F-Secure, with Secure, and now RiverSec. So from very early on, we focus on an approach which was not only offensive driven, but also engineering driven. And we all studied physics, and that's why we got involved before the term IoT was invented, way before that, into testing everything from the smallest chip to the largest product. And that's why we're here now.
All right. So what's changed over the years?
Well, the very first years, of course, in this industry, was very hard to convince that security was important, especially as an investment for the future, and particularly also on devices, hardware, or intangible things. And so the evolution of all of these technologies came a long way. I remember we were one of the very first groups to publish an automotive security talk back in 2007, I think. And in the last slide, we mentioned, that as a warning for the future, maybe the impact of what we're presenting now, it's not so severe because we were hacking the only data channel that was available on a vehicle from the outside, which could only carry a few bits per second. But the last slide said, in the future, maybe if cars will be more connected, this could be a warning. And now, of course, we know that we can control vehicles from an app, that we have self-driving cars, we have AI on them. So the ecosystem changed a lot. So I think that's what really changed.
All right. So, I think you already touched upon this, but what does secure product development even look like in today's world where everything's connected to everything else and it's just a whole mesh of things?
Yeah, well, so as with physical threats, because of course these kind of threats are also there on products that are not necessarily connected to anything, but it's the same mindset. The journey starts from embedding security from the very beginning. And the problem is when security becomes an afterthought. So the earlier we're engaged into even the design, the conceptual design of a product, the better it is the outcome of doing a security effort throughout the life cycle of the product. So we work with customers and trying to get involved as early as possible. Otherwise, we just have to assess where in time of the product life cycle we are, and then we take it from there, and we try to gain as much insights, as much lessons, as much knowledge for the future iterations of the product. But we consult customers at any stage of development. Sometimes it's very late, the product is already out there, or sometimes the product is on the drawing board, and then we can have very different kind of conversations. I think one of the key expertise there, and that's also why I think experience matters, and not just knowledge, but also the experience over time, is to be able to handle all of these situations. An engagement that comes from an security engineering perspective, or architecture analysis perspective, design, is very different from a penetration test that only comes on a product that is already on the market. And in the same way, the effectiveness, the kind of mitigations for problems and flaws that are found is also a very different exercise in these two different types of products. Sometimes patching hardware, firmware, or software once a product is mature is extremely challenging, if not in certain cases impossible. While if you're early on, maybe you have very important decisions to make. Maybe some of them you cannot even test. You you kind of have to rely on your expertise, and so it's a very different kind of mitigation that happens. So very different type of engagements, while obtaining the same goal in the end, which is to have a secure product on the market.
So what about different industries? Like, when you're talking to manufacturing or automotive or finance, what are the biggest security challenges there? Are they the same? Are they different?
They're very different. Like ultimately, the building blocks, like the very primitives that we're dealing with are the same, but the context makes them very different. So the banking sector is one of the sectors where we can very easily explain the fact that we have very diversified experience, and that, as I like to say, that we touch the entire stack of things. Because if you think about it, you go from the individual check that is present on a credit card, which we also published research on and we did a lot of testing on, to the point of sale device, which used to be kind of this simpler device, and now they are almost like a full phone with operating systems which are very complete. They might have apps, but they are, a very important piece of equipment that take part in the transactions. Then you can have ATMs, but you also have the banking backend, the banking mobile applications, the banking website. So in the banking industry, the financial industry, you touch pretty much everything from the chip to the most complex infrastructure to deal with transactions. And then, of course, if we want to add into this mix the cryptocurrency theme, it becomes even different. So for these customers, engagements can be very different. They can touch any of these elements, if not all of this pile of technologies that are out there. Or it could also be pure security engineering. I mean, we develop a lot of bespoke hardware security modules for the cryptocurrency sector, for instance. So it could be very different. In automotive, on the other hand, we're talking about an environment where you have products which have a very long lifespan. I mean, if you buy a car, you expect the car to be safe and sound for many, many years. There's a lot of certification involved, and it's a very different kind of certification compared to, let's say, the banking sector, because here we also have to deal with safety and not only security. And you have millions of products out there. A recall can be very costly. So it's very different from the ecosystem of the banking industry. However, they share some similarities, of course. They both use hardware security modules, but they're very different. The hardware security module that you would find inside an automotive MCU, it's a very different kind from the one that you would find in the banking industry. So again, same building blocks, same technologies. In the end, we're talking about computers. It's all the same, but the context makes it very, very different. The timelines, the time that you have for a project is very different, and also the consequences of security problems.
All right. So in all that time when you've been doing this, I'm sure you've come across like many interesting and cool stories. Is there something you might want to share? Something like a real world example where offensive security testing has revealed a critical vulnerability in a product?
I mean, happened many, many times. There are many things that
Sure.
we cannot discuss. But what I can say is that, so we tested entire aircraft programs, for instance, and we prevented issues that might have, in a very specific context, they might have affected the safety of the plane because of a security issue. So we're not safety experts; we are cybersecurity experts, but we really work there to understand the interaction within cybersecurity and the safety domain. So I think it was very interesting to see the effects of a cybersecurity incident against this kind of equipment. Now, of course, what is comforting for us and for everyone is that we were part of the solution, not the problem, because we were involved very, very early on into the development of an aircraft. And this is precisely why we were involved. But I think it was very interesting to work along with the engineers to find unexpected results and to work together to somewhat change this approach that maybe cybersecurity professional hackers, they don't want to see products improve, but we actually do. We go hand in hand together with the engineering aspect. So I think that was very interesting for me as an exercise.
No,
In,
absolutely.
yeah, in other areas, I mean, we went from not knowing anything about a target in automotive to have full control of a vehicle over like remotely just by
Mm.
access through a cellular network. So again, um, really scary but to do, very unexpected, but these are exactly the kind of things that we're trying to test and exploit and then help mitigate. So I think these were, I guess, the commonality between these two examples is that they both somewhat bridged the virtual cybersecurity domain with an
Mm.
actual physical impact. So I guess that's why they popped to mind, because they were very impressive in terms of the consequences that they had in the end.
Yeah. So one of the things we promised to talk about today is trends and mega trends. And I remember a couple of years ago, all the industry talks were about IoT and cryptography and things like that. What's happening there? How are these things evolving in the context of secure product design?
I mean, in terms of IoT, of course, we don't see the distinction anymore.
Yeah.
Everything is IoT, right?
Yeah.
Once upon a time, we used to make the distinctions. Now we expect everything to be connected, whether it's a smartwatch, it's a washing machine, or the smallest of objects like light bulbs. So now that's common. Everybody expects that. So I think the trend there was that it's not a distinction anymore, and
Mm.
people understand probably the problems that are associated with it. And so that's, of course, is good and bad. It's good in the sense that that also puts more emphasis on security and more expectations from customers in terms of quality and security of these products. On the other hand, it means that we have a lot more targets. The market is massive, and it means that the quality of implementations can be very diverse. And this is why certifications like the Cybersecurity Resilience Act are jumping into somewhat set a bar for the security of all things, all products, because it cannot be an afterthought anymore. So this is one aspect, and the second aspect, of course, in we see this AI trend, which is massive. It's apparently unstoppable, and so we see that this technology is being even, forcibly uh, implemented on pretty much everywhere. There's this push in the industry to just try and adopt AI on everything, and so I wouldn't be surprised if, as we were forecasting, washing machines having connectivity, probably washing machines will have AI on them in the future. And of course, that comes at a cost. It's a technology that needs to be integrated. It has its consequences, and we see people pushing it even to the hardware. Of course, there's an inherent aspect of these technologies that the hardware needs to be aware of this of the kind of computation that is
Mm.
needed to perform these processes, and that, of course, is pushing the industry to create a lot of new hardware to back these kind of runtimes, and that also has security implications. We see new GPUs, new system on chips, new parts coming out, and of course, when you do product security, the landscape of the parts, which I mean the chips that
Mm.
are available out there, is important.
Yeah, absolutely. But like, we're not just following these trends. For example, in security research, Riversec is shaping these trends. What does that look like, and what sort of an impact are we having on the industry?
Well, every time we do an assignment, as we try to also have the engineering mindset, if we see the opportunity for a tool, a framework, anything that can improve mitigating the anti-patterns that we see customers are applying that leads to security problems, if we see the opportunity to create something that can solve those patterns, we take it. Sometimes it means publishing offensive research. So we
Mm.
have a long-standing tradition of publishing vulnerabilities that come across our work. If they touch anything which is open source, anything which is third party, then of course we publish those. But we also have a long-standing tradition of publishing tools that help solving these issues. I mean, we went from providing simple tools that aid for instance, enabling secure authentication on classes of chips to make that process smooth and efficient, to promoting entire compilers that allows to have memory safe code running everywhere, and to somewhat disrupt traditional concepts about, certain programming languages can run here and others can run here, to somewhat break the trend and provide a tool that allows to solve entire classes of security problems just by design. So we are always on the look for these kind of aspects. Personally, I also enjoy doing projects, and we're doing a lot of projects which are actually open source contributions in the security engineering or security vulnerability arena, which we're also allowed to share, which I guess it's a win-win scenario for us. We combine research and publication and improving ecosystems and made it available for anyone that wants to use it. So there's also that we have a keen eye on that as well.
So speaking of combining things, this sort of contributing to the sort of scene or community, wider community, is that's part of your hacker background, and you're combining, like, you're a living example of combining that hacker expertise with security engineering. That's what the whole team is doing. So what does that look like in practice?
So in practice, it means, so I always like to say that sometimes, not every time, but sometimes it's very easy to point the finger at a problem in cybersecurity, but it's the actual resolution of that problem which is hard. Because maybe it could be easy to solve in theory, but in practice, given the state of the product, the life cycle of the product, the engineering needs, demands, or the business demands, it becomes really, really hard to do it in practice. And I think maintaining the engineering aspect, which means knowing how things are built, and not how they're built, in theory, but how they're built at scale, that makes a whole difference. Because then we can engage with a conversation and an actual meaningful collaboration with all of the engineers involved into creating a product, so that our work as security consultants is not intrusive, but is collaborative. Because it's very easy for a security consultant to play the part of the professional that is intruding into a process in a way that is too disruptive. And in the end, that means it's counterproductive. The goal is not reached. And so I think the engineering mindset is critical into turning the results of an audit, of a penetration test, of a design review into something which is actionable. And we go as far as developing hardware, firmware, software, even owning that code for the customer is if for some reason the solution requires expertise that the customer doesn't have, and they cannot onboard people with that specific knowledge. So we even went as far as developing hardware components, hardware modules, firmware, bootloader software, libraries for them to embed into their product, which in the end means that we also become engineers. We become engineers and owners of parts of the product, components of the product that, of course, they were created because of a security mindset, but in the end, they will be very operational, and that's a big responsibility. But that's how you also create this self-feeding loop of making, which then comes back into knowing how to break things. I think it's essential to know how to build something if you want to break it, and the other way around. You need to break things to understand how to build them better.
Yeah, you got to have both. And on that balance thing, I want to sort of bring you back a little bit. You were talking earlier about the security principles as they are, the wider principles, but then also like very industry or sector specific needs. How do you then balance these things?
I mean, it comes down to expertise. We need to touch all of these different industries in order to have good knowledge about them. And this means that sometimes the knowledge is very specific to a very specific sector. Again, the cryptographic algorithms that we would use for developing an HSM for a cryptocurrency exchange, they will be radically different when we develop secure data loading for an aircraft. But sometimes there are huge cross collaborations between these two words, and I think also that's important. But that comes with expertise, knowing what's the right tool, um, the right practice for one specific vertical opposed to the others. And also sometimes just be brave and break a trend. There have been many cases where we convinced customers to change very long-standing patterns in certain industries. In automotive, this is a classic example where for a long time it was very difficult to get unstuck from very specific way of doing things. And if we see that's what it takes, then we're not shy in proposing an approach that somewhat breaks the conventional wisdom in that specific area. And I think having applied successfully those same security practices in some other very mission critical industries, I think goes a long way into providing confidence. It's not always successful, but the time that it has worked out, it somewhat reshaped the industry, at least for these specific verticals and customers.
Yeah, that makes sense. So if we talk about the whole sort of life cycle, security life cycle of a product, what would you say are the key stages where security should be embedded in, like from concept to deployment? Is something more critical than the others?
I mean, ideally, every stage has its own security approach. But as I
Mm.
mentioned before, the earlier on, the better. It's a sort of different decisions that needs to be made. Um, if we're talking about an implementation bug, it's something that can be very later on in the stage of development be found and be mitigated. But sometimes there are design decisions that are critical, and that one decision opposed to another can completely prevent the need for a lot of different security testing, because certain issues they are just completely eliminated from the very beginning. And sometimes it's as simple as deciding the kind of connection that goes from one component to the other. If you make, for instance, the right protocol break, you can completely mitigate an entire classes of attacks. And it could be a choice that is actually has no impact on the operation of the product, has no cost associated to it, but it would prevent so much testing later on and so much pain in case there's a problem. But this should not be confused for implementation issues that you can find later on, even if you make the right decisions. So I would say that every stage has its need for security, but there are certain ones, especially the early ones, that can be so much more cost effective to have. And sometimes there are certain kind of bugs that if you're not there at the right time early on, you will never be able to address. They're just going to be there forever. So I think there's a need for a comprehensive approach in these kind of development life cycles. Each step plays its part, and the late you are in the game, the more costly it can be in case there are problems.
Yeah, yeah, that makes sense. Um, all right. So, how is Reversec preparing for what's coming next? What the emerging mega trends in tech and infrastructure? What does that look like? And by the way, before I let you answer, I want to remind our audience that we will have some time for audience questions later. So keep those coming in. But sorry, sorry, Andrea. So emerging mega trends. How
Yeah.
are we preparing for those?
I mean, I think it's somewhat inherent in the work that we do, that we get to see a lot of products in very early stage, and which means that we sort of get a glimpse, a preview of what is to come, right? Whether we're looking at the dashboard of a vehicle that is going to come out next year, or we're involved into designing banking applications, banking modules, or we're being asked to implement, post-quantum cryptography on products. I think that means that we sort of get of a preview on how things are going to be incorporated, and also means we get the chance to make them right. I think the academic world, very in recent years is improved a lot in security. We used to say many like 20 years ago that academia was not a very good ground for seeing what's next in cybersecurity, but that changed a lot. I think the academic sector now it's making very good contributions, both on the offensive as well as defensive aspects of things, and also in everything cryptography related. And so I think one of the way that we adapt is to take a closer look at what's being published, not strictly into the realm of cybersecurity conferences, but also in the academic sector, and to be on top of what is there and the attacks, the protocols, and again, to try and get as much as security engineering projects. Some of them, they are proof of concepts, to integrate these kind of technologies and to find the best match. So I guess, in other words, what I'm trying to say is that if you only live in a consulting world where you're just doing pen testing, I guess you get a sort of limited view on what's to come. But the fact that we are heavily involved also in developing products, in designing product, in advising, that gives us an entirely different opportunity in the way we look at things, because it's not just limited on testing something that is already there, but it gives us the chance of creating and using what is the state of the art, the best possible solution. And sometimes it means something that is really new, not something that is out there, because that's the way it is, because attackers and attacks, they grow at a faster rate than defense mechanism.
Yeah, I know. I mean, even in traditional, as you said, even in traditional security, they've been talking about shifting left for like ages. But sounds like you're saying in product security, this is actually happening to like a wider degree. Why do you suppose that is? Is it just the immutability of hardware, or like what's driving that?
No, I think the key difference is that while hardware, of course, is immutable, usually hardware is not very mature. So the software, the firmware that you put on hardware doesn't get mature immediately. It's kind of like, you have a game console, and
Mm.
you know that for the first years games are not going to be as good as they can
Yeah.
in using the hardware. It's the same thing with conventional hardware. So, but I guess the key difference is that with product security, you get to see every layer. You don't get to see the hardware. You get to see the way the hardware gives support to the firmware, the way the firmware uses the hardware, the way the software uses the hardware, how all of these things are combined. If the software needs to worry about hardware concerns, or if the hardware needs to worry about software concerns, it's a tangle of many moving parts, which also just doesn't is not just constrained on the product itself, but on the ecosystem surrounding it. Is there an infrastructure which is needed to run that? I mean, let's talk about an EV charger.
Mm.
You have the cable itself as technology, the vehicle on the other side, which could also be seen as a threat, the infrastructure for making sure that you can use your mobile app against the charger. I mean, the charger is a product, but there's so many things surrounding it, and they touch every aspect of technology. You need to be keen on testing web applications, mobile apps, hardware side channels. And so I guess that's why product security is very complete, because you sort of need to be a master of everything in
Mm.
order to declare a product as secure. And that gives, I think, a very different perspective to just focusing on a very specific area, which you can do if you're limiting yourself to, let's say, web applications and so forth.
Yeah. Okay, that makes sense. So, what's happening next? Like, what are some of the innovations in product security that you are sort of most excited about right now?
Well, I mean, personally, I am very excited about the fact that there's a strong push in open source, even for chips and for hardware. We see new designs coming out, and also the ability now for everyone to make chips is increasing a lot. I envision that a few years from now, the same way you make a printed circuit board, you will be able to make a system on chip, and I think that's important because the fact that all of this information is being made available means that attackers have better ways of understanding how things work and to simulate them and mount attacks. The technology is much easier now to achieve. And on the other hand, implementers, they will have opportunities that were unheard of before, such as, if I need to make my own chip for that design, I can do it. And I think, I don't think we're quite there yet, but there are a few companies that are taking this approach, and I think it's a very interesting trend for me personally. Of course, the other trend that we mentioned before is AI, and we'll have to see how that pans out. But it also means that we need to be aware of it, and we need to understand what the interactions are there between, again, hardware, firmware, and software.
Yeah, I mean, I guess by law we do have to talk about AI.
Yes.
So, so that's I mean everything that's going on right now. So, what are your views on AI?
I mean, it's it's a technology that I think is extremely powerful, and it's being made accessible in a way that it's unexpected for the conventional user, which is why sometimes people don't quite have the understanding of what's going on. But the thing is, it is not required to
Mm,
use these kind of tools. But it also means that the implications are not quite understood, both in terms of social impact, but also technological impact. I mean, we've seen these posts of people putting on LinkedIn the resume and then putting a message for an LLM so that they can spot where a talent scout or a recruiter is automated or not. So these it's a sort of it's kind of like a reinterpretation of the SQL injection, or I don't know if you remember, there used to be these memes where you put a SQL injection on the license plate of a vehicle, and
yeah,
so
yep.
if your car gets on a speed camera and there's a SQL injections, then you trigger that. I somewhat feel this is somewhat similar, right? We have a playground to try and experiment with these things, which is sort of unexpected for most people, but not for the cybersecurity professionals. And I think that's sort of interesting to me. But what is interesting more to me is the hardware aspect of it. I'm seeing so many parts now being designed and coming out with the specific acceleration that is needed for AI. And from my point of view, that's interesting for me because it will give us more targets, more products to either break or test. And I guess in a way, it will also push more the ability of manufacturers to build more chips, which I think in the end could be good because that can also means that we're going to have more mature secure boot implementation, for instance, which has nothing to do with AI, but just because a new part comes out because of AI,
Mm,
then it means that we sort of have this new cycle of parts. And I guess that's the angle that I have on AI on my side. On the specific aspect of the impact of LLMs, I mean, I think it's a very personal trait for consultants to how to use them and where to use them.
mm,
Again, like every technology, I think if you use them effectively and in the right context and with the right sandboxing, they can help you. But it highly depends on what's the workflow of a person, their knowledge or not, because sometimes they can be very, very counterproductive, and sometimes they're not. It's kind of like programming. Each one has their own style. They like their own language. They have their own problems, and I think personally for the problems that I have, which requires parsing a lot of specifications and finding the right bit that needs to be turned on and off, I kind of like that to be a personal journey where I read all of those pages and not asking an LLM to do the job for me.
yeah.
Because personally, I think I learn a lot just to find the relevant chapter that I need. Because maybe by doing that, I read a lot of other sections that I didn't know I needed. And so I just don't want to take the shortcut. So that's the way I see it personally.
Oh, that's beautiful. See, now that I have you sharing these personal perspectives, could you just share one sort of unconventional attack vector, or something that surprised you and gave you a new perspective on product security?
That's a very interesting question. I think that recently there have been a lot of side channel attacks, which are really really interesting. Finding ways to flip a bit.
Mm,
So sort of emulating what a cosmic ray does when he hits a chip, but not by not doing it by pure chance, but trying to control that. And of course, we've seen a lot of fault injection attacks that came out in the past years. And at some point, there was Rowhammer, an attack where
mm,
you could simulate these kind of effects, but by software. So by software, you could flip a bit into a neighboring memory line and sort of have this induced cosmic ray that wasn't coming from the universe, but it was very local. And that, I think, changed perspective for a lot of people, because it was a clear um, crossing of the threshold between software and hardware. You were doing something purely by software, which was doing affecting the hardware at the lowest possible level with catastrophic effects. So I think that for me was something that I kind of felt that it could be done, but I couldn't quite put my fingers on it. And then, of course, brilliant researchers, they did it. And I remember that I saw a paper which kind of hinted at the fact that memory had this problem. And then there was another group that actually exploited that. And I think that that was great. That changed. I think that changed the landscape and the perception of the importance of hardware security in relation to software security, and the other way around. I think that that for me was one of the biggest milestones in this industry.
No, I can see how that would be the case. All right, so we do have some audience questions already, but please keep them coming until the very, very end. Um, so the first question is, what does it look like when security is baked in from day one? We talked about this a little bit, but like, can you just like paint a picture for us?
Well, the picture is that the scope of subsequent audits becomes much more narrow, because what typically happens is that the attack surface, so the all different ways and concerns that one need to map before mounting a penetration test, becomes so much smaller, because you see from the very beginning that a lot of interfaces, a lot of protocols are really locked down. So it means that as an attacker, you are completely removed from a lot of opportunities to do to mount a lot of attacks that simply is just not there. It could be that certain storage is connected with an interface that doesn't allow you to have direct memory access. It could be that you are using protocols where the parser is secure and doesn't give you possibility of manipulating the input in a way which is negative. It could be that the hardware itself has hardware-backed security features that prevent you from taking a chip with memory, desolder it, and then put there a chip which has an older version of the firmware, because you have active hardware mitigations that will detect that that specific occurrence happened. These are decisions that need to be made early on, because otherwise you don't have the chance to roll back these features afterwards. And if you do them from the very beginning, certain categories of attacks are nullified.
Yeah. Okay. There's another question that sort of, I think, ties into this while being a little bit different. The question is, when assessing smart cards, point of sale systems, or HSMs, what distinguishes a mature implementation from one that only appears secure on paper?
I think the role of compliance and certification sometimes is used as the only way to achieve security. If you look at compliance and you tick all the boxes of a certification standard, it doesn't really mean that the product is secure. So we tested countless systems which were certified, and that they were in one way or another, even rushing ticking those boxes. But in the end, when put them to the test, they were not secure. And I think that's one of the distinguishing factor in this specific industry. When we find a mature product, we see that the certification is an outcome, and it's something that happens after a solid foundation is present. And these products, they look very different. I think one with experience can really tell when something is compliance driven, opposed to something which is very well designed. Sometimes you even, when we open, for instance, a point of sale device, and we just look at the PCB, like the printed circuit board, sometimes you can also tell visually if that was designed because it needed to meet compliance standard, or if there's a solid foundation to it. I would say this is one of the distinguishing factors that that affect this specific vertical.
Okay. The next question is on the automotive industry. Why is my car so great, but the infotainment system isn't?
Huh. Well, so I think things are getting better these days because the role of the infotainment is becoming unified also with other safety critical components. So there's more attention also in that part, but it didn't used to be the case, and it also used to be that the team developing the infotainment system were very different from the teams developing all the other body controllers for the car, all of the other automotive MCUs. So and also there's been a huge rush in adopting smart infotainment system in the industry to sell vehicles that were more appealing. And I think that was rushed, and it happened before the advent of over-the-air updates for vehicles, which meant that if you buy a car at the wrong time of the life cycle of this technology roll in, you will be just stuck with that infotainment for a long time. I think things are getting better now because infotainments can be updated remotely in most of new vehicles, and I think things will improve in the next years. But I think we're suffering a little bit with this sort of adoption, which was too rushed without updates or simply done with different quality, different teams. And it's a very competitive market, the automotive one. So with very strict timelines and deadlines. So you don't delay a vehicle because the infotainment doesn't quite work. So it's that I guess that's also part of it.
Mm. All right. There are a couple of audience questions about sort of your assumptions that and how they break going into testing. One is specifically about what types of assumptions around components and SOCs typically break down during testing. And the other question was about sort of because pen tests often assume patch availability. So in hardware or embedded context, what assumptions change because
Yeah.
that's not as readily available?
Yeah. So we tested a lot of system on chips, particularly in the secure boot implementation, because that's one thing that you cannot patch. I mean, again, we say you can do remote software upgrades, you cannot do
Mm.
remote hardware upgrades, and secure boot is one of those technologies which authenticates the code at the very beginning. It's essential to maintain a root of trust, and it is embedded in the silicon. So we tested a lot of secure boot implementations. A lot of vulnerabilities we publish on this front, and so that's typically one of the most catastrophic failures that you can have. Maybe you need secure boot for actual security, but also compliance. And if you find a defect in that implementation, then the entire root of trust breaks apart for certain physical attacks against the product. And so, yeah, what it looks like is that the security model changes dramatically just because something very early in the boot process in the boot ROM, which is in the silicon that cannot be changed, has a failure. And so that to us is it's a very practical problem. Other kind of problems in system on chips is debugging features that cannot be meaningfully disabled in a meaningful way. And so, yeah, we test all of these things, and some of them you can mitigate, but some other are not, which ties to the second question. Yeah, patching hardware is impossible, patching silicon is impossible, which is why we want to be involved early on. And sometimes we can affect the part number decision making process. There is a chance to change the part, otherwise there's no chance to change the part. And so we need to find the best possible solution to meet the security goals, which sometimes can mean that you are not going to meet all of them, and you need to understand if that's an acceptable risk or not. And
Mm.
again, it's a complex process because it highly depends on the context, the attacks. Uh, some security issues, they can be left there. You just need to be aware of them and to account for them and act accordingly. And some others are catastrophic. It really depends on the kind of product that we're talking about and the context.
Sure, sure. Okay. We have a question here where I can literally feel the pain of the person asking this question.
I'm
How
sorry.
do you convince stakeholders that security isn't just about things breaking, but about building better products?
That's a very good question. Usually it's a journey. I would say that the most typical uh, assignment that we get is later in the development of a product, even though we're very lucky that because of the reputation of the team, we are getting increasingly involved just at the very beginning, which is great. But I would say that the average customer, it's about pen testing a product that is considered to be mature and that it's almost on the market. And usually that's a learning lesson. That's a learning lesson for the customer, the development team, because of course, when we make a report, we list the problems, but also the mitigations, but also the root causes of what led to that problem being present. And we explain what needs to be done in order to mitigate that problem from just happening in the first place. And that's the moment where we engage in a conversation about the next iteration of that product or the other
Right.
products that that specific customer makes. And of course, it's also about building trust, right? Nobody expects that an offensive security team can just jump in and then start designing products together. It requires, trust, being able to prove your experience and to prove that you can have a meaningful collaboration with the team, which again doesn't necessarily rely purely on experience and know-how, but it's also relates to being able to work together well and speaking the same language. And again, that's where the engineering mindset comes in, because otherwise, in my experience, it can be challenging. But that's the conversation starter, and that's where we start, engaging with the customer on future projects, and then we just keep repeating the same pattern, but with less pen testing, because
Yeah.
again, we just shift from the later development stage to the early one. So the nature of the involvement with the customer somewhat changes, which is
Yeah.
great.
Sure. Sure. All right. We have a balancing question here again, which I love. Industrial environments are retrofitting smart capabilities onto legacy equipment. How do you balance security and security controls with constraints imposed by old architecture, strict uptime requirements?
Yeah. So yeah, I mean, there are two techniques for doing that. One is isolation. You isolate the components which are legacy, and so you accept the fact that they have limitations, but you monitor them.
Mm,
There's never such thing about 100% security. I say that even if you assume 99% security, it's more important to control what happens in the 1%. And so in these cases, that's the approach you take. You know that those components have a limitation, and you isolate, you control them. And we tested a lot of retrofits, especially in airplanes. You get a lot of older systems where you need to do crazy things in order to retrofit them. Like I need to emulate a floppy drive because I have a floppy disk interface on the other hand, and so I need to emulate that because I don't want to change the avionics, but I want my floppy to be connected, for instance. And so that comes with very interesting kind of tests because you have very bespoke design which they bridge very very different words, and they're slotting in the modern ecosystem of the connected world into something which is much simpler and not designed for that. And so in a sense, I would say that when you retrofit something which could be even for security purposes, it does come with its own security challenges. It's a very unique field, and again, I feel very privileged that we got to also work on these kind of topics. But it's certainly something that happens. I would say that it only happens in very specific industries, though. Uh, Fast-paced, fast-moving industries, they tend not to have this problem. This is traditionally a problem in the industrial world,
mm.
aviation world. I would say even the automotive world, with its long lifespan of products, it is much faster than this. So I would say it's somewhat constrained to very few verticals.
Yeah. Okay. So the final question I think we'll have time for is touches on a topic that I don't think we covered too well. Given the long certification and manufacturing lead times in this industry, we talked about shifting left. When is the right point to in the life cycle of our product to run testing, given that you still have to go through the certification process and things like that?
That's very good question, but a very difficult question because it entirely relates to the specific context of the product and the way it is developed. There are
Mm.
certain tests that you can run very early on and that they have no bearing and they have nothing to do with the certification. And there are some others that inevitably you have to wait for a certain implementation to be mature enough, not only because they're needed for the certification purposes, but also from a security standpoint. So there cannot be a simple answer to it. With the most complex ecosystems, we engage with customers with recurring tests. Certain products require dozen different engagements a different time of the years over across different years. But I would say that the earliest we're involved, the better we can draft a timeline and a counsel on when the right time is. And this is something that you can only develop by keeping the pulse of the development and being in touch and having the right set of milestones and deliverables being laid out. But there cannot be a simple answer to that. If it would be easy, if this would be an answer that we could reply here, then the world would be a better place, a much easier place to deal with, I'm afraid.
That's perfect. That's a good place to wrap this up. Thank you, Andrea, for being with us today.
My pleasure.
And I want to thank our audience for tuning in and watching this either live with us right now or watching the recording later. Thank you for being here, and catch us next time.
Thank you very much.